Welcome guys. So I think we can start now. So today's topic is the pgstat monitor, a feature-rich and enhanced version of pgstat statement. So welcome here. My name is Ibrar Ahmed and I'm a principal engineer at Percona. So here is my small bio, so what I have done last many years actually. So the database performance basics actually. When we're talking about the basics of the performance of database, the one thing we already covered in the previous scalability and that session, but in here the basic concept is you need to learn what your queries are doing. Are their queries doing good or bad? The queries are good or bad? What are their performance? So first thing first is you need to learn which query is doing bad and what queries are running on your database, and that's really important for you. So you already tune your database, everything is good, but if your queries are not perfectly good or it's a bad, so you need to have a knowledge of that queries. So user often do not know that they have such queries. They just, a developer wrote some queries and they are not performing really good. So you need to figure it out that which queries are good and which queries are bad. So if you know that, then you have to fix it. But before fixing, the knowledge of that queries that not working properly, they are bad, they have performance impact, that's important. To which queries are they? So actual parameter in a statement, like you need to learn that when you analyze your query, you need to know that when you run your query, sometimes it's run perfectly, like select static from foo, any table, where id is equal to, if id is equal to greater than less than 1, maybe there is a one row, the query runs really fast. But if you have a query like greater than 1, maybe the query is almost the same, but it has the performance impact because it has to retrieve all the rows where id is greater than 1. So that's points actually. The exact value of that parameter is important. So the second, the bucketing, because you need to know when you have a monitoring system, then you are accumulating all the data at once, but sometimes you need the bucketing time. Like you want to know that in which hour I have the query is taking the more time. So that's important because you have an off-peak hours, you have an off-peak hours and peak hours. So you need to run which are your peak hours and which is your off-peak hours, where when your queries are taking much time and at what time your queries are not taking much of time. So another, also you need to capture your failed query. Sometimes it's happened your queries are failing. So need to know which queries are failing and which queries are passing. If query is passing, taking time is a separate issue, but if query is failing, that the capturing of that data is also important. So response time distribution, the histogram, sometimes you need that this query, the same query runs, take much of a time at that span of time, and at that span of time, different span of time, it taking less time and some other time it's taking more time on that. So that's also important. So plan information, query hierarchies, these are the information you required to monitor your database. So here, there is a pgstat statement that it's a PostgreSQL extension. It's available in country module. You can install your pgstat statement and it can give you the idea to monitor your queries. So you can have the query, the exact text of the query. You have the calls, how many times this query has been called. Then you have on a total time, min time, max time, average, how many rows it retrieved, database name and the username, on which that query runs and which user has run that query. So you have that information in pgstat statement. But keep in mind that this is the built-in is a part of the PostgreSQL distribution, this query, this pgstat statement. but it lacks some information we have discussed in the previous slide, like the plan information, the application name, and lack many things in that. So here the Percona have a tool, a PGStat monitor, a PostgreSQL extension that provides more detailed statistics about the execution of SQL statement. So it provides the more detail, it stores the statistics in a buckets. Like PGStat statement store all the information as a whole. When you start your database, then it will start accumulating your statistics, and you can get the average and mean time, max time on a whole set. But in PGStat monitor, you can create a buckets, like you can create a buckets of 5 minutes. So you can have 5 minutes aggregates of queries. So that's important. So I will show you how you can do that. And it also have more information than PGStat statement. It's not like that. PGStat statement, I think, have 36 to 36 columns of information, but PGStat monitor have around more than 50 columns. So it has more information, like IP address, from where this query is coming, the application name, from where this which application is running that query. That's important. Sometimes you need to know which application is running that query. So that's important. So this kind of information you can find in PGStat monitor, which is not available in PGStat statement. So it's free, it's open source. You can go and download from GitHub page. If you want to have a package for that, so we have Percona have that distribution, that repository, and you also install using the pgxn. Pgxn is a PostgreSQL extension mechanism from where you can just run pgxn, install PGStat monitor, it will install the PGStat monitor. So if you want to build from the code, here are the statement for building the code. You can change, you can contribute to that code, everything you can do that. But if you need packages here and the So how to install PGStat monitor? So PGStat monitor, you need to perform two tasks. The first task is you need to load that library, because it's not the library that you can just install that library and it's working. You need to load that library into PostgreSQL.conf file. It's a PostgreSQL configuration file where there is a parameter shared preload libraries, and it is PGStat monitor. Just put PGStat monitor there, and then you need to restart your PostgreSQL, and that PGStat monitor required restart. And same with the PGStat statement. If you want to use PGStat statement, just put it here, PGStat statement here. So it will install PGStat statement. But here we are installing PGStat monitor. Other way around, you can just set alter system, set this alter system, and then you have to restart the system too. So the both ways you can do that. And after that, the PGStat monitor start collecting your statistics. So it doesn't matter you create an extension or not, it will start collecting the information at the back end. So, but you cannot see that information. To see that information, you have to write create extension PGStat monitor. But before that, the statistics already been collected from the PGStat monitor. It is just, it will create some views to see that information only. So it will create an extension for you, and there is a two concept of the SQL version and the build version for the PGStat monitor. When you do the PGStat monitor extension, you can see this. The default version is 2.0. It will install your 2.0. Current version is 2.0, and you can install it, and this file will run in a background. It's quite a detail. So if you do that, PGStat monitor version, so it will give you the version, which version you have. This is a minor version 2.0, and it's a minor version 1. So you can see the version of PGStat monitor. So PGStat monitor has some more column than PGStat statement, I told you, but for some of the columns are like the bucketing. I will discuss the bucketing next. The bucketing time, the client IP, from where that query is coming. the plan ID, the planner, the query plan. It will show you the query plan of that. And the top query, okay, top query ID and the application name from where that query is coming, and the relation, how many relations are there in the query. All right. So we will discuss one by one. So I'm not just the command type, error message, CPU time, and the stuff is there. So the bucketing, that's the most important thing in PGStat monitor, that you will set the bucket, how many buckets you need. So here you have 1, 2, 3, 4, 5. You have a 5 bucket. You set that in configuration parameter, I need 5 buckets in the system, and each bucket is like 1 minute. All right. So you run your query, and you can see that in the bucket 1, you will collect the information, all the aggregates in 1 minute, it will be in bucket 0. And when this time is elapsed, 1 minute, the second minute, it will start collecting the data for bucket 1 and have an aggregates, the average, mean, everything for that bucket. And it's a round robin, like bucket 0, 1, 2, 3, 4, and when the 4 is complete, then it will override the bucket number 0. So here you can see the bucket number 0 that has this statement. This statement has called 2 times. Bucket change, it said it's 1. In PGStat statement, if you see that command, it will show you the insert into command 3. The value is 3. No, it's a different one. If that query runs multiple times, so it's just adding that. But in PGStat monitor, it will just add that for that bucket time. If that is within that bucket, and that bucket number show, so at what time this bucket start, and in which bucket it has the average, aggregation, and everything in that. So using that bucket, if you want have an application like we have on a PMM, the PMM where we can show the per minute information, aggregate for per minute, you can just get the latest bucket and show that into your screen. So every minute you just show that information on your screen, and you will get that aggregation and everything from PostgreSQL, PGStat monitor. So query information, it's same like PGStat statement. So here you have a user ID, dat name, and query ID, query, and calls. So you can see all the queries here. It's almost the same like PGStat statement. So it's just almost the same thing. But here are some information I want to show. If you see this one and this one, there is some difference. If you want to see, I will show you in next slide. And difference is, if you see, the value is actual values. 561. It's called. The difference is, I'm just missing here. The difference is here and here. In PGStat statement, we don't have the application name and the IP address. Here the IP address is a local host, it doesn't matter actually. So you can see the IP address and the application name, but in PGStat statement you don't have that information. So you have additional information than PGStat statement. So query monitoring. So query monitoring is like when you are monitor your query. So sometime initially I told you that when you are monitoring your query, it's really important to see the actual value of the parameter. Like in PGStat statement, you have statement like this: select A from foo, where A is equal to the value. You write 10 here. But when you see that in PGStat statement, it will show you the placeholder $1. It will not show you the actual value. So if you write it 100, 200, 300, it will always show you the $1. But in PGStat monitor, we have a mechanism where you set this normalized queries false. If you set that parameter, you can see the actual value of that query. So previously in PG stat monitor we have that information only, but in PG stat monitor if you set that normalized query is false, then it will show you the actual value. So why it's important? Sometimes it's really important because actual values sometimes take more time. Like if 1 million records are there for 10, where A is equal to 10, there is a 1 million record. So this query will take more time. And if A is equal to 1, there can be only a 1 record for that. And this query will run for A is equal to 1 will run fast, and A is equal to 10 will take more time. But in pgstat statement, you cannot see which query is taking more time, a 10 or 1, because it always show the $1. But in pgstat monitor, you can see the actual values. So you can try that which actual value is taking more time. So that's another feature that pgstat statement is not providing to see the errors. So like you write a query like some query like select static from pg underscore foo. There is no pg underscore foo table is available. So you write that query. But if you want to see that in terminal, you can see that the query doesn't work. In your application will get the error. But in the log, you can see that there is a error in that. You can fix that, like a relation pg input does not exist. A pgstat monitor will collect that information for you. So another way is you can get the log of PG PostgreSQL and see that errors are occurring. But in pgstat monitor, it accumulate and give you the actual value that relation PG input does not exist 10,000 times. That means your application have some error and is continuously running that query. So you can get that information. So you can see that, oh, that's a problem. We have to fix that query. So it can be the any error, like it's a syntax error here, but it's a logical error here. That's like 1 divided by 0 divided by 0. And in this case, sometimes your query is right. Here your query is not right because you are getting this error because table does not exist. So it can be possible. But the second query is important because you have some mathematical functions in your query. And it's always like select 1 by 1, 1 by 2, 1 by 5 like this. And sometimes it hits 1 by 0. So you go to the pgstat monitor, you can see there is a divide by 0 error. It is not in your query, but in your logic where you are getting the parameter from. So this is the logical error here, and that's a problem. So you can get that you have to fix your mathematical function, you have to put some check there in your code that it never happened, divided by 0 error. So it's not only the syntax error, it also get the logical error where some exception is coming. So you can get the code, actual PostgreSQL code, like the code, the query, the level of that. If it's a warning, it will show you the warning. It's a fatal, it will show you the fatal. It's any kind of error, it will show you here. So another important information is the timing. So if your query, if you running a query multiple times, it happens that you run a query multiple times, like you have running a query select static from pgstat database, and you are continuously running that query, and total time of total calls of that statement is 24. You call that statement 24 times. So you want to see, you create a histogram like a 1 minute histogram and 23, 0, 1, 2, 3, 1, 2 and 10 histogram. You can configure that I can have a 10 value histogram and per minute value, per second, per millisecond. So first this take, suppose this is a 1 millisecond, it's a 2 millisecond, 3 millisecond, 4, 5, 6, 7, 8, 9, 10, 10 millisecond. So this query runs, take 1 millisecond 23 times, and this query take 2 millisecond, and it doesn't have any value because it doesn't have value. And this query take 3 millisecond one time. You got my point? The histogram, like this query take 23 times, runs in 1 millisecond. And the second one, 2 millisecond, no. 3 millisecond, yes, one time it take 3 millisecond. Like this. And the last one is if take the greater than 10 millisecond, all the values goes here. And if take less than 1 millisecond, so all will go here. 1 or less will go here, and greater than 10 and equal to goes here. And these parameters are configurable. You can configure how many histogram values you have and what is the values in between them. So it will show you that this query will take multiple time, 1 millisecond, 10 millisecond, 20 millisecond, and how many time it will take that time. And that's called the histogram. And next we'll show you the here. We show you the exact statement line. Here you can see that the frequency 2, it shows that this query is 0 to 3 millisecond. It takes 0 to 3 millisecond, it runs 2 times. And here 10 to 31 millisecond, it runs 1 time. If so, like this, so you can have that, you can see the frequency of that query. You have planning statistics in PGStat monitor, like you can see the how many time this query planned and how many rows, relatives, queries and calls. So here plan calls, this query is planned 100 times and this query has planned 0 time and this query planned 10 times. So you can see how many time it planned, how many time it get from the cache. So if it's less than the actual calls, then it will get from the plan from the cache. So other than that, and this is the really important thing that PGStat statement is missing. If you run your query and your query performs really bad, so what will you do? The one thing is just you copy that query and explain that query and get the query plan. But the problem is that in this case, when that query was run, at that time plan was different. And when you try that plan to debug that query, the plan can be different. And that's the major problem. So, and mostly people are doing, they see that in PGStat statement that this query is taking much of the time. They just copy that query and explain that query in terminal and say, oh, there is plan is right. But at that time when that query runs, at that time plan was not right. So PGStat monitor provide a parameter, a query plan at that time when the query runs. It will get the plan from the cache and exact plan it will show you the value of that. The only drawback of that parameter, it will slow down your database, so it's not recommended. It's by default it's off, because if continuously getting the query plan for every query in your system, it's not a good way, because it will take time. So when you want to debug your system, just turn it on and it will show you the plans of every query. Yeah, top query is also really important. Like if you have a store procedure, and you have a query, multiple queries in that. So PGStat monitor will capture both, like it will capture the add to and it will also capture the select 1 and 2. So like if you have select $1 and $2 within the add to, and you have an other statement select 1 and 2 which is not part of add 2. So it will treat it like the same in PGStat statement. Like it will show you that it doesn't matter if it's within the procedure or outside the procedure. So in PGStat monitor, we have that information that this select $1 and $2 and its top query is add $1 and $2. It will show you the container of that query too. So other than that, it will also show you this query and the top query. top query is important because if you are running, like you have a select one, normally select one, and you have a select one within your procedure, which is taking much of the time. So you can debug that. So you can segregate your queries by the command type text actually. Like if this is a select query, you can see that this is the select query. This is the update query, this is the insert query, select query. So insert, update, delete, and insert, update, delete, and select. So you can get that information that this is a select query. You don't have to parse this query, just like that. This is the select query, this is the select, update, and we are not doing that. I just truncated that query, so it's coming down. That's why it's not showing the select. So, but we are not showing for the truncate and vacuum. We are not doing that. We are just selecting the insert, update, delete, and select. So there is a other parameter. I don't want to discuss much of that because a lot more than that, like the client IP, top query, the comments, the plan ID, query plan, top query, application name, relation, error level, code. So there are many parameters we have added in pgstat statement. So it is all there. So here, pgstat monitor in PMM. PMM in a Percona's monitoring tool. So where you can see you can select the values, you can see the value, the query, insert into, it will show you the values, the load, the everything, query count, query time. It will show you all the information. It's very small, but in PMM you can see that all the information using the pgstat monitor. It collects the information. You can see the client host, the IP. You can click that. It will show you all the information from that IP address. The username, the service name, node type, everything you can select it here from here, and it will show you all the information in PMM. So here the same slide that you can get all the statistics using the PMM. So it's also the histogram. Unfortunately, when I was running that in PMM, all the queries take 1 millisecond. So it's a histogram. So all showing that this query take 0 to 3 millisecond, 10 to 30 millisecond, and 1 second. So all the queries have 1. So if different, you can visualize that in a different query times. So similarly, I show you in PSQL that we can get the plan after query. But similarly, you can get that information in PMM. It will show you the query plan. You just click it here, the plan, and it will show you the plan of that query. But it's important that the query plan is enabled in pgstat monitor. So you can get that information. Otherwise, you will not see any information here if it's disabled in pgstat monitor. So PMM will show you the query plan here. So there is a service to PMM. How to add that into a PMM? That's a separate thing. So the feedback. So you can always create a Jira ticket. You can reproduce the issue. If you find any bug, anything, you can just report it, and the feedback is needed. So that's a simple tool that you can use it in your production to get the monitoring of the system. So any question, anything? No, actually, he was joking actually.
One question, when you change the normalized query text value, it shows you the number of calls, right? Does it then separate them into calls? Like, does the value of calls change as the aggregates the query?
No, actually it will aggregate using the placeholder, but it will show you the slowest query only, the value of slowest query only. Got it? Yeah. Yeah. For that bucket, absolutely. For that bucket, the slowest query, it will show you the exact value of that. Otherwise, if it's 1, 2, 3, it was just expanding that this is a different query, like if it's y is equal to 1, then it's a different query, is equal to 2, that different query. We are not creating different queries. We are just putting the placeholder, aggregate that, and put the value which is take the maximum time.
So if you show the slowest query, it'll still say count is maybe 10, even though the slowest version only ran.
Yes. Yeah, it's independent. It's an independent extension. So yeah, it's have the columns of pgstat statements, but it's not dependent on pgstat statement. Its functionality is little bit different, but with more features. Still have, if you have any question? Nope.
When you install this extension, if you want to do some background tracking,
Yes.
I mean, 1 month long, it will slow down the whole system.
Yeah, currently we have a benchmark on that, and pgstat statement will take around 3 to 4% degradation. pgstat statement 3 to 4% degradation, and pgstat monitor have 6 to 7, but with extra features. Absolutely, when you have, because when you install pgstat statement, it will degrade your database to 3%, 3 to 4%, but with 35 columns. But when you install pgstat monitor, it will go to 6 because it has more than 50 columns information. When you collect more information, you have to bear some performance degradation. Yeah, that's a trade-off actually. But keep in mind, when query plan is off, if you are capturing the query plan, it will go to the 15%. But it's not recommended. By default, query plan is off. Because we can't do that, because we are fetching that query plan from PostgreSQL, and that's its requirement that it will degrade the performance. So normally it's you put it off and you have some problem in the database, you turn it on and see the query plans and then turn it off. Okay, I think we're done.